So hi everyone, welcome to the AnandTech podcast. I'm your host Ian Cutress, and joining me today is Ryan Smith, our editor-in-chief.
Hey everyone.
We're here in San Francisco reporting from Intel's Developer Forum 2016. It is 2016, right? I'm not just sleep deprived.
It is 2016.
It is 2016.
Although the products we're looking at are basically all for 2017, so...
Yeah, this IDF was not as, exciting as last year. Last year's IDF was all about Skylake and Skylake's macro architecture, and I remember being sleep deprived then as well.
Being sleep deprived, it's a tradition really with any of these developer conferences. This
year, we're talking a lot more about Atom. We're talking a lot more about Xeon Phi. Now that Xeon Phi is being launched around this time frame, and also next generation Xeon Phi. And because, despite this being Intel's event in San Francisco, a lot of other companies decide to hold their events nearby during the same week. So yes. We also have some AMD news about Zen to talk about.
Yes, it's very convenient when all the journalists are already here that you only have to show up with a few people.
Yeah, you could say it makes it cheaper, but AMD aren't the only culprits in taking advantage of events in other locations.
Mm-hmm.
So let's talk about what happened at the beginning of the week. You and I attended the Intel Keynote on Tuesday morning.
We did indeed.
Bright and early, with Brian Krzanich, the CEO of Intel, on stage talking about what he finds interesting in the space and what Intel is doing in the future. And one of the things that he presented on stage was Project Alloy, which is Intel taking on virtual reality again.
Yes, very much so. I mean, so Project Alloy, in a nutshell, is a self-contained VR headset. So as opposed to Oculus Rift and Vive, where they're just the display on a head unit and then all the processing takes place on another computer, this is an all-in-one. Processing is on board, battery is on board, so you just put it on like a very large hat, and there are no wires.
Untethered experience is one of the main points that they're going for here. That Intel is of the opinion at this time, despite the fact that current virtual reality implementations are still good for their products, the best virtual reality experience is going to be one where you don't have wires, but also you can dynamically interact with your scene without any additional tools.
Yes, Intel likes to call it mixed reality. It's basically VR with reality projected into it, as opposed to augmented reality, which tries to project an image into the real world. This is the real world projected into your fake world.
And they do this using two Intel RealSense cameras. They didn't say whether it was the old RealSense or the new RealSense.
I would assume it's the new RealSense, but it's such an early prototype, it doesn't really matter right now.
We're practically a year out from seeing any content being developed by general developers with Project Alloy. This
is a very early prototype. They don't even start sending prototypes out to developers for another year. So
yeah. But the idea, now we've seen almost untethered headsets before. I'm not sure if you remember the Sulong Q that was advertised by AMD about 8-9 months ago.
Yeah, I was at the Kasaken event at GTC 2016 where they showed it off. I don't want to knock these things, but the Sulong Q was underpowered for what it needed to do.
Well, the idea is that you use a combination CPU, GPU, which AMD calls their APU, into a headset. So you are limited on power inside a headset because you're not going to have a 50-watt heater on your face.
At least you hope you aren't.
If you are, then you may need to consult your physician. But the idea is that in a device like this, you're practically looking at a 7 to 10 watt limit, slightly more than a smartphone, because it's something that you're going to perhaps use for an hour. Mm-hmm. But at that power, you need to still be able to drive a display at 90 hertz or whatever configuration they think is best. No display and no refresh rates information was given. Like I say, it's literally early prototype stuff. Battery life, again, is going to be one of those things, and what Project Alloy does is the rear of the headset, where other VR headsets have straps, they actually have a compartment which is just all battery. There were some at the show. We didn't have time to actually try one to see, how heavy the battery is or what battery life they're expecting or what the end product should be like. But the idea is that you have this virtual reality headset which computes as is untethered, additional battery, uses dual RealSense cameras to be able, so you can see your hands, as in literally see your hands in the game, and the projection of your hands can adjust based on what the game wants you to do. So one of the demonstrations they showed was moving your hands in front of an in-game X-ray machine will cause it to turn into a skeleton, and it uses 5-finger tracking, so you can actually see all the joints in your fingers, and you can use your hands to interact with the environment. That being said, untethered experiences means you might bash into walls a lot, or TV, or the cat, or more dangerous items like the swimming pool.
Yeah, and again, this is where the whole prototype thing comes into play. With the depth sensing camera, the camera can, at least in principle, tell you when you're about to run into a wall or anything else, but they have to be careful about what they sense versus what they project in the world. You don't necessarily want the wall projected into the world when you're still 5 feet from it.
Yeah, you have to have that buffer. And it's exactly how big is that buffer and how quickly are you going to run into it. 20 miles an hour usually. Just splat in the face. We'll see that happen, I bet.
It already happens with HTC Vives. The chaperone system is quite good, don't get me wrong, but people still manage to go splat every now and then.
So one of the aspects of the dual cameras that they really liked to show off is this idea of unlimited workspace or unlimited desktop. So you can have the headset on and essentially have an unlimited resolution display of work windows. So for anybody that uses more than one monitor in their workflow, it's not a case of just having monitors side by side, it's a case of having monitors everywhere, 2 inches from your face. And they were talking about 2D applications on top of 3D environment manipulation, all done on this what we assume to be 7 to 10 watt SoC. It's going to be tough. It
is. What it was is it was a concept video, so it was all rendered. This wasn't anything they demoed live. It's just a vision of where Intel wants to be in, say, 5 years from now. So they still got a ways to go. In particular, you need a much higher resolution display to comfortably project 2D desktops into a 3D world. But it's an idea they're pursuing. What can you do with mixed reality?
And in order to enable this, they are actually opening up the RealSense APIs for developers to use.
Correct.
So we might see it used a lot in enterprise and commercial environments, medical and engineering and everything else.
We will. RealSense is more than just the Alloy headset. In fact, with the recent Joule IoT announcement, it's meant to be used in part with the RealSet gear. So Intel's also pitching RealSense at the IoT market pretty hard. Nice
segue into Joule.
Thank you.
Also announced during the keynote was Intel Joule. So Joule follows Intel's ever-expanding IoT maker, hacker, whatever they want to call it, space, which includes Quark, Curie, Edison,
Galileo.
What else am I missing?
No, that was it. You did well.
And they all scale up from low die area, low power, low compute, all the way up to Joule now being the new high-end IoT system, slightly bigger than a stamp, I think.
I'm going to say closer to a
stick of gum.
Stick of gum, or maybe a Sony memory stick.
What, you mean like the old? Oh, you mean like the old PlayStation 1 memory cards?
No. The memory stick set for Sony devices in the early 2000s when they decided they wanted to try a proprietary memory. Anyhow, so slightly larger than a stick of gum. But yes, Joule is the...
I can tell you here, it's 2 inches by 1 inch, essentially, by 3.5 millimeters.
Sounds about right.
So yeah, Joule uses the new Intel Atom core.
Correct. It uses the Broxton SoC. This is confirmed by Intel, so no guessing here. Broxton, as you may know, was a code name more closely related to tablets and smartphones initially, but Intel decided to get out of that market, so Broxton for smartphones and tablets was canceled back in April, but the SoC lives on now, going into Joule and other devices.
We will see it on various mini PCs and everything else going in the future, or at least the SoC style design under Apollo Lake.
Yes, exactly.
Is definitely for that space, that and embedded. But for IoT, Joule has 4 Atom cores. These are the new Goldmont microarchitecture.
Correct. Goldmont cores, the higher-end Joule unit, the 570X actually has those cores turbo up to 2.4 gigahertz. So we're talking about, for a small IoT device, a lot of CPU power, all things considered.
Did they give a TDP for the unit yet?
They did not give a TDP for the unit yet. However, you can buy them on the show floor, so worst case scenario, you could always plug one in and just see how much energy it's pulling.
Yeah, I mean, the quad-core Silvermont stuff used to draw anywhere from watts to more watts.
Yeah, quad-core Silvermonts could draw 4 or 5 watts.
Yeah, so I mean, it's definitely going to be for the high-powered. I mean, the example they gave was drones running automated RealSense type tracking materials.
Yeah, and the cool thing about Joule is that there's finally enough processing power to do this. The previous high-end kit from Intel, and I use high-end loosely, was the Intel Edison kit, which used a Silvermont generation Atom, dual-core Atom clock, very low, at 500 megahertz. So just in terms of CPU power, the Joule kit offers 2 more cores running at a minimum 3 times speed. So you have, just by straight math, 6 times the CPU processing power. But the really cool thing is that Edison did not have any sort of graphics subsystem. Intel disabled the built-in GPU on that one, because this is just meant to be more of a sensor module, but Joule has a fully enabled Gen 9 GPU. I don't know how many EUs are on this one. I don't know if it's 12 or 18, but it's there, it works, and it means you can use the GPU on Joule to do computer vision now.
So when it comes back again to the drones following people, being able to see what's on the display, then using the GPU, either the fixed function hardware or the execution units, to determine that's a person, that's a tree, that's a wall, I should go where the person is, and
Exactly.
Applications therein. This is for their maker communities to figure out. And the kit price, I think, is listed online on Mauser at something like $399.
Yes, Intel was selling them here at IDF for $369 a unit. This is the high-end 570X kit. The lower-end 550X kits and the individual boards without the developer kit parts will go on sale in Q4 for presumably a lower price.
Yeah. So just to round out the specs of Joule, we've got 4 gigs of LPDDR4 on the high end, 16 gigabytes of eMMC, and 802.11.AC, and the standard I/O, I2C, and USB 3.0. So it's a fully functioning x86 unit.
Yeah, it's essentially an x86 mini PC on a gum stick.
Right. Okay. Let me put this to you. Something like this, being able to follow you around, connected to the headset you're wearing for VR, it moves dynamically so you don't trip over the wire, and it does all the compute. So you do have an untethered experience, as in there are no wires to a fixed location, and it's smart enough to get out of the way when you decide to shoot zombies.
Well, admittedly, I don't know why I'd have it follow me in the first place, but what I'm envisioning in my head is trying to fly a drone while wearing an alloy headset, and I can see that getting very sicky very quickly.
Oh, we'll see. Like I say, Joule expands that line of Intel IoT. Now, don't get me wrong, Intel's IoT market strategy can come across a little unfocused because they have so many products now filling up every power and compute usage scenario. For them to be able to define their product line over the next 12 months, I think, would be important if they want to take part of the 50 billion IoT devices we keep hearing about in the future. It
is. At the same time, it's very much a evolving market, so they want to just throw things out there and see what sticks. Things like drones, robotics, industrial IoT, these are really just ideas for what to do with Joule. It's up to Intel's developers here to actually take it and put it into practice. At the same time, talking about Intel's market share, Intel is going into a market that's really not very well served right now. Most IoT kits are based off of really low power gear. Quad-core Cortex A15s, A7s, A53s. Very, very low power gear without a ton of processing capabilities. Really the only other kit in the space is NVIDIA's Jetson TX1. So NVIDIA and Intel are more and more at loggerheads with each other every year. And this is one more area where Intel is stepping in and having a go at NVIDIA.
It's going to be fun to see. So, speaking of Goldmont cores in Joule and the Broxton SoC, we also got more details on Broxton as a next generation Intel Atom processor. This was cunningly hidden in one of the talks, to which there weren't that many attendees. I was quite surprised. They weren't overly saying everything, like they gave vague estimates of clock speeds, but they essentially laid out what the SoC will have in terms of core and subsystem. We found that Broxton in Apollo Lake will have either 12 execution units or 18 execution units. It will have an DDR3L interface, except that one of their slides had LPDDR4, and the people who were discussing this seemed a bit confused as to why one slide had one slide had the other. We got Gen 9 graphics again, as we mentioned. Now, so these Gen 9 graphics are different to Skylake's Gen 9 graphics.
It is, and it depends a little bit on how you define it. If we talk about just the shader cores, basically the basic graphics rendering hardware, how pixels are pushed, trials, etc., it is the same Gen 9 that's in Skylake. The difference really amounts to is that Intel has outfit Broxton and its derivatives with a different, newer video processing block than what we saw in Skylake.
Yeah, and with this, they specifically said, we now support HEVC encode and decode in fixed function hardware. It's no longer a hybrid between fixed function and execution units. It's now low power.
Pure fixed function, very low power, kind of thing you can do potentially in milliwatts. There are some basic limitations here. You only get 8-bit HEVC support, but for the kind of devices that this is going into, that's perfectly fine.
And now you can buy a mini PC which will power your 4K display, 4K encode and decode.
It is. All things considered, Broxton is a really nice step up over the previous Cherry Trail, Cherry View generation Atom SoCs. The one unfortunate bit is that we don't know anything more about Goldmont. Goldmont, according to previous roadmaps, is supposed to be a fairly significant upgrade to the Atom core architecture.
So this is going from previous generation Silvermont-based cores.
But Silvermont, Airmont, yeah.
Yeah. So Airmont to Silvermont to Goldmont is the core names.
Silvermont to Airmont to Goldmont, but yes.
Yeah. And the SoC names Bay Trail to Broxton.
Yeah.
Alongside with Broxton, they will introduce enhanced temperature SKUs. So previous generation they removed that functionality. This is for embedded applications which require temperatures down as low as -40 Celsius or up to 110 Celsius, because in the industrial markets those things happen. Mm-hmm. 3 displays at 4K, 60 Hz, though not HDMI 2.0.
Yeah, they were somewhat unclear about this point, but yes, you do get three displays at 4K. So when we're talking about 4K displays, think digital signage systems as opposed to anybody trying to run 3 4K desktop displays.
Yeah, with desktop displays you need a high chroma, so you can actually determine what letters are on the screen.
Yeah.
Whereas for moving pictures, that's not necessarily key. They said that Broxton would be from 6 to 12 watts, which is what the embedded and mini PC market needs. Support Windows 10, support flavors of Linux and Android, and a couple of other projects that they're working on. We asked about Windows 7 support, and they said not directly advertised. They want people to move on to Windows 10.
Yeah,
because it's easier to support.
Between Intel and Microsoft, they're doing what they can to get people to use Windows 10. It's more than just Windows 10 is the new shiny. It's that Windows 7 now is 7 years old. When it was released, Sandy Bridge had yet to hit the market, so it has it has no innate built-in good concept of all these modern power technologies.
But no doubt somebody will want to use it somewhere, so...
They'd have to find drivers.
Yep, find drivers. But we expect when Broxton is launched to have the full mini PC and NAS market adopt it. People have been asking for this, so it's coming. They didn't exactly say when, just it's coming.
Yeah, the discussion really was.
It's in Joule.
Yeah, and that's it. The discussion was mostly Joule centric. Apollo Lake not really being talked about here.
I saw a motherboard on the show floor. For embedded.
For embedded, okay.
So there was an SoC with a heatsink and a PCI Express bus connector.
All right.
But that's it.
Yeah, I expect we'll hear more about Apollo Lake once devices are actually close to shipping.
So speaking of atom cores in small numbers, let's talk about atom cores in large numbers.
Ah, yes, Knight's Mill.
Well, I want to start with Knight's Landing, which is the current Xeon Phi X200 family product. This is Intel's answer to high-performance computing in both scientific and data center environments using 72 atom-styled cores.
Yes.
We've talked about it for almost a year.
Oh, longer than a year. Knight's Landing was originally announced in 2013. It's taken Intel a while to get out there. They've been very forward in their development in order to give their developers an idea of what's coming. We already know what's going to succeed Knight's Landing here in a couple of years.
So while they've got Knight's Landing in for the HPC crowd, when Knight's Landing was envisioned, computer vision, convoluted neural networks, machine learning wasn't really on the tip of people's tongues for hardware acceleration.
Correct. Yeah, Knight's Landing, very interesting, very cool design. It is meant for the traditional HPC market, 32-bit and 64-bit floating point, stuff as many large, complex numbers in an AVX unit as you can and let it rip.
So this comes on to the next generation Knight's Mill, which is...
kind of sort of the next generation. Knight's Mill is an unusual announcement. So here's the thing. Back in 2014, Intel announced what, as far as we know, is still going to be the true third-generation Xeon Phi. And that is called Knight's Hill, emphasis on the H. We have not heard anything about Knight's Hill lately. However, as far as we know, it is still in development. It will debut once the 10-nanometer process is good and stable and able to make large chips. In the meantime, at this year's IDF, Intel announced Knight's Mill, emphasis on the N. Knight's Mill is a Xeon Phi part, but it's not an HPC part like Knight's Landing. Instead, Knight's Mill is, as Ian mentioned, focused on convolutional neural networks, really the deep learning markets where you need this really fast performance at low precision.
The Googles, the Facebooks, the Baidus, Intel's major 7 partners in machine learning are all big multi-billion-dollar companies with lots of data to churn through.
Yes, the Super 7, as Intel likes to call them.
And the idea is that Knight's Mill will feature a variable length vector unit. I mean, you were there at the presentation. What did they say?
Yeah, so a variable length vector unit, they didn't specifically mention any specific precisions, but it's a foregone conclusion. It's at least going to have accelerated FP16, if not even smaller fixed precision and integer formats. Again, very high-level overview, just a single slide here. They laid out the basics. Variable precision, better scaling in large clusters, and really just trying to make the most awesome deep learning training processors that they can.
One of the issues they're going to have is that we see a lot of deep learning applications benefit from moving from floating point to fixed point. And that improves not only power and speed, but it's also comparable in accuracy with a lot of algorithms that they have now. So
it gets a little complex for inference, which is actually executing a neural network. Say, for example, when your car is driving on the road, then yes, you can generally get away with very low precision. That's where you can get away with AND8, that kind of thing. For actually training a neural network, you often, but not always, need somewhat better precision. So if this is really a chip for training neural networks, then it may just be FP16 focused. But again, we'll see.
Yeah, they didn't give any indication of, the sort of power budget they're aiming at, or what form it's going to take, or what's going to be inside, or how it's going to be connected. Just that, here's a code name, it will be aimed at machine learning.
Correct. And it'll be here next year, and it should offer, at least for the deep learning market, significantly better performance than Knights Landing.
So, that's Intel. Let's talk about the news of the week, where AMD kind of said, hey, come see what we're going to talk about. And so, we've come to... how to describe this? When a company says, come look at our product, which is several months out from being released, we're going to tell you more about it. You typically expect it to be a very high-level marketing fluff for partners. This is what you're going to expect. Keep excited. AMD did something different.
Exactly. And just to add a little color commentary here, AMD events are historically very big on the fluff. I don't mean this to be too harsh towards AMD, but it just tends to be what they do. Instead, they came out with something very different from what we were expecting. Very, very focused, very on the point, much deeper than we were expecting.
Very professional.
Exactly. It was exactly the kind of event they needed to present, and they really knocked it out of the park, I feel.
So, we didn't get fluff with Zen. Now, we know Zen's the new microarchitecture from AMD. It's their relaunch into the high-end x86 market. And one of the questions that's always been on the tip of everybody's lips is, how exactly are they going to do it? And they hired back Jim Keller, who has very good design wins with AMD and Apple in the past, to come back and help design this. And he spent 3 years at AMD and left again, so the rest of the team could just bring it up from the microarchitecture. And we got a little insight into the high-level microarchitecture about decode, about execution ports, about cache sizes and bandwidth.
Indeed we did. And what it is there's going to be a deeper presentation from AMD next week at Hot Chips here in California. However, for their larger press event here, they went deeper than we were expecting by actually giving us just some basic high-level details about how the chip works, enough to sort of whet our appetites ahead of next week.
It's very difficult to describe it in a podcast like this, so I encourage people to go read the piece that I was up until 3 AM having to write, given the fact that they announced this in the evening to say, get ready to post it at 6 AM the following morning.
Mm-hmm.
So we're going to a level of detail which is in line with essentially how much information they've given. They can always give more information, and I keep drilling them for it. But there are a few big changes to how AMD has designed the next generation microarchitecture. We now have a micro-op cache.
Yes.
Which allows the CPU to essentially have a very small buffer next to the dispatch buffer. So instead of it having to go out and decide what operation it needs, if it's already been used recently, it can just pull it from closer in. It was the feature that made Intel microarchitectures such as Sandy Bridge very powerful when they were launched compared to the current market.
Exactly. I mean, micro-ops cache is not the only thing that has made past architectures good, but if you look at everything AMD has done with Zen, and there are many things in fact we don't know about, just seeing a micro-ops cache, it brings a huge sigh of relief, because that's something that we know in other designs has proven to be very powerful.
They didn't say how big it was. They didn't say how powerful it was. They said they have better branch prediction, which every CPU manufacturer says every generation, which is fair enough. The cache sizes are extremely different to what they've done before, to the point where they're doing a lopsided L1 cache in terms of instructions and data, and the lopsidedness is offset by the associativity, so it's sort of a tit-for-tat arrangement. Lots of L2 per core, so we have half a meg of L2 per core compared to Intel's current implementation of a quarter of meg of L2 per core, which means that AMD Zen is going to have more immediate data in a lower latency cache than Intel, which, assuming it arranges the loads and the stores correctly, and how that cache is utilized, I think, is going to be important. And then we have an L3 cache, which is at 2 meg per core. And so the Zen chip is going to be an 8-core chip. They've said that before. It's going to have simultaneous multi-threading. So we're going to have 2 threads per core, similar to what we've seen on Intel chips for a number of generations now.
Yeah, and this follows the same logic as why Intel implemented SMT, why IBM's PowerA implements SMT. When you design a wide core designed to extract a lot of IPC, you are going to have functional units that just aren't utilized. You're going to have ALUs or load store units, etc., that don't get hit by a thread in that cycle. So you use SMT, throw in another thread, try to light up those units.
AMD didn't say anything about, supporting extended AVX instructions or some of the more high-powered compute functions. The idea of Zen was to be a high throughput small core that will return them to the high end. And Jim Keller was essentially given carte blanche to do what he thought was best. The fact that AMD went into this level of information surprises me at this stage of the game. I mean, they even gave dates on when we can see Zen. So Zen will be. The Zen core will be part of the Summit Ridge platform, and Summit Ridge platform will exist alongside the Bristol Ridge platform, which uses the current generation architecture. They will share a socket for desktops, and we will see system integrators will have access to all the chips and designs ready for their systems to be in the market end of Q4, with Zen available to system builders, Summit Ridge available to system builders in Q1. Now, AMD originally said Q4 2016. Yeah, that slipped. But Q1 has a number of important events in it to which AMD could launch at.
Exactly. You have everything from CES to supercomputing conferences.
Yeah.
To an event AMD was told if they want to hold their own event.
Well, we were discussing yesterday that nobody really launches a CPU in Q4.
Generally not.
Because holiday season is when people want to gain market share and sell everything really cheap. If you're returning to the high end, it's a premium product.
Exactly.
AMD did show off a canned benchmark. We'll be honest, we cannot confirm any of the specifications to which AMD said the system was run, or if the systems were run at the same. But they said against a 8-core Broadwell E at 3 GHz and an AMD 8-core Zen at 3 GHz, running the same workload based on Blender, which is a rendering program, the two CPUs on their benchmark workload performed almost equal, with actually the AMD Zen part having a 2% improvement, which in this benchmark equated to about 1 second in 50.
Yes, and the idea was for AMD, they're trying to show that at least under this scenario, Zen had a similar IPC as Broadwell, which, if that's the case, is a very big deal for AMD, as they now would have an IPC equivalent to Intel's similar high-end multi-core chips.
If AMD come out with something that matches Intel's high-end desktop, I mean, the part that they used, admittedly it was downclocked 200 megahertz from its base, but that's a $1,090 part at retail.
Yes, it is.
All they have to do is come in with a similar part at around 700, and they're assuming that benchmark was correct and can be applied and expanded to other workload scenarios. You have to take the result with a grain of salt until you can actually, with a pinch of salt, until you can actually do the test yourself.
Yeah, with these early benchmarks, there are really two different ways they can go. Obviously, AMD is not keen to show their hand to Intel any earlier than they have to. So maybe this benchmark was picked because it would show IPC at only Broadwell levels, and they may even be exceeding it. So it may be a sort of a trick to Intel. On the other hand, this may have been a benchmark picked because it was a best case scenario. We don't know right now, but what we do know is at least in one benchmark, and Blender is a fairly important app, that AMD is able to show similar IPC as a current generation Intel processor. So it'll be interesting to see what we find here once Summit Ridge starts shipping next year. We can throw it down on a test bench and see if that IPC similarity is real and where else it exists.
A couple of the analysts at the show were saying that AMD has to temper expectations because they don't want to overhype people too early. I mean, the point is when we get the chip into test, it will have to perform at least at this level, because if it doesn't, there'll be an uproar.
Exactly, and AMD has had issues controlling customer expectations before. So far, they're doing a better job of this with Zen, and it's all the more to their benefit if they can continue doing a good job of this.
And the fact that the event was, as calm and metered and straightforward as it was, and not, hype jump around.
It was. Lisa Su wasn't promising to revolutionize the world. She was just out there to promise that she was going to deliver a good chip, and that's a message AMD got across very clearly. That said, there are going to be a few unknowns here, not just in terms of architecture, but in terms of total performance. What we saw was a demonstration to show IPC equivalence. What we don't know is what clock speeds can AMD hit.
Power consumption.
And power consumption at those clock speeds.
So is it as efficient?
Yes, the 1-2 punch from Intel is that they combine high IPC with clock speeds of 4 gigahertz or more. If AMD has similar IPC to Intel, and they can deliver similar clock speeds as Intel, all of a sudden, it's a brand new game. And if they can do that while also delivering the same power, then it's a two-player market again.
If you can equal efficiency and if you can equal die area as well. I mean, we've always said, a number of people have always said, including us, that Intel's 14 nanometer process is very competitive in high performance, and Global Foundry's 14 nanometer is new.
It is. I mean, they're both called 14 nanometers. They're really not comparable. Intel's 14 nanometer process is probably a generation ahead in terms of density. The way these processes get named, it's really no longer.
It's a noun almost.
Yeah.
It's literally a name, not accurate of what's actually happening.
Yes, 14 nanometer means it's smaller than whatever came before it. In this case, 28 nanometer Global Foundries. But yes, Global Foundries uses a 14 nanometer process licensed from Samsung. It's already put in production for AMD's Polaris family of chips, so we've already seen it in action a little bit. So it'll be curious to see how well it does with a high clock CPU.
And speaking of Polaris, die size, Global Foundry's die size history isn't necessarily up that large. But AMD also previewed their server part, which would be a large die size part.
Yes.
This is Naples.
Mm-hmm.
This is Naples. So AMD's 8 core design comes into a 32 core, 64 thread server CPU in the second half of 2017.
You want cores? AMD has cores. Oh, will AMD have cores?
So what they showed off. They didn't say much about Naples, but what they showed off was a motherboard, a dual socket motherboard with two sockets designed for designed for Naples-based CPUs. So you can have 64 cores, 128 threads in a dual socket server. With they showed eight DIMM slots per socket. Now whether that's quad channel or 8 channel, we don't know. We don't know PCIe lanes, we don't know power consumption, we don't know if there's any changes in the cache hierarchy, because we know that Intel has a semi-modular design when it comes to enterprise products in that space. It's almost a complete unknown, but they had a working server, working dual processor server running Windows Server 2016, I believe.
Yes, it's obviously very early silicon, probably just barely runs, but it's enough to show that it's out there. They're able to get a chip out there, and that they are aiming very big for their potential server customers next year. The server market is very important to AMD. One of the strengths they had back in the good old days, as it were, the K8 and Opteron days, was that they were able to tap into this server market with Opteron, and the server market has much higher gross margins. It is Intel's bread and butter. So if AMD can reestablish themselves in the server market here, then they will be in a much better position in terms of profitability.
And alongside servers, they also mentioned notebooks and embedded for second half of 2017 as well.
Yes, Zen cores start out big, high-end desktop servers, then they start making their ways into APUs, embedded, and other such devices.
So when Intel comes out with a part, and they say come out mobile first, and then eventually it expands into desktop and server, they're spanning the range all the way from 4.5 watt dual core to 140 watt 24 core. But the fact is the core design goes from one end of the scale to the other. AMD is not as big as Intel, so they can't hammer the market at each stage all at once, just because they don't have either the revenue or the personnel.
I agree.
Or the resources.
With Zen, it's important that they bring up the CPU on its own first, get that right, and then they can start doing things like building it bigger, mixing them with integrated GPUs and such.
AMD's always been a fan of catering to the enthusiasts, in the fact that the enthusiasts will drive the market every other generation, every other design. So you get the enthusiasts on board, then you go for market share. Then you get the enthusiasts on board again, then you go for market share. It's an interesting strategy, and I think next year is going to be, again, very interesting. You and I are going to have a lot of work to do next year. I mean, we've already had a lot of work to do this year.
So we'll be up till 4 a.m. at IDF 2017?
Yeah, we'll see about that.
Yeah, overall, the AMD presentation, it is one of optimism, cautious optimism to be sure, but optimism. It's AMD showing that they have what they need to at least take a stab at being competitive again with Intel, something that they just haven't been able to do for the last 4 or 5 years.
I want to test it. I want to test it now. Give it now. I keep telling AMD, give it now. Unfortunately, I don't get anywhere. I keep bothering them. I'll do a Shawshank Redemption. I'll post a letter every week for 6 years.
Well, think of it this way: we're in California. We know AMD has working systems here. We know they're presenting hot chips next week. All we have to do is track down the systems and liberate them.
Yes, and then face legal action.
But you would get to test it first.
Yeah, it's a trade-off. Is there anything else at IDF that caught your eye? I know you went to a few different talks that I did.
No, I think that really covers all of it. It has been an interesting show for sure. Just perhaps not as enthusiast-centric as in past years. There's some things out there on NVMe, some things on FPGAs, now that Intel has their Altera acquisition complete, so they need to project their future plans to the Altera customers. And so it's a very interesting show, just a wider show than in past years.
I was expecting more about Optane and 3D XPoint, to be honest. I know it's a technology that Intel want to keep very close, very personal, so they can maximize the sales to when it eventually comes to market, both in enterprise and consumer. I was kind of expecting a bit more information on it, though.
I agree. After last year's Optane IOP performance demonstration, we're expecting a little bit more, but I can certainly see the value in waiting until they have something that is commercial ready to really show off.
Well, Supercomputing 2016 is in November, and it kind of get the feeling that may be a relevant launch schedule.
It might be. If not a launch, then at least close enough to retail availability that they can show off performance in greater detail. Maybe start talking about pricing. That's going to be a big question mark. Optane obviously is not going to be price competitive with SSDs. We know them, even enterprise SSDs, but just where's the price going to fall? The picture I get from Optane is that it's increasingly being tuned to be used as a mid-level cache between RAM and SSDs.
Well, one thing I did notice was that rather than talking about products, they were talking about hierarchy and being able to program the system for it to see both the DRAM and the Optane SSD as a contiguous set of, essentially making the DRAM a buffer to the SSD. So you can, while your system may only have 256 gigs of memory, which in the enterprise space is small for a reasonable database, if you also have, say a couple of terabytes of Optane storage, yes, it's slower, but it's faster than an SSD, and it's non-volatile, then you can turn the system into saying, hey, look, I now have 2 terabytes of memory stick my database in there, and you will get a speed up compared to it just being on standard SSDs or SATA drives.
Exactly. It's your typical memory hierarchy play. Just in terms of computer science in general, over the years, we've added more and more layers of caches and memory because it's not been possible for long-term non-volatile storage to keep up with the memory bandwidth needs of systems. We started with hard drives and core memory, then we added L1 caches, L2 caches, L3 caches. We've got
EDRAM.
Yes.
EDRAM as a write back buffer, then as a DRAM buffer.
Mm-hmm. SSD caches for hard drives before people went pure SSDs, etc. So this is essentially another layer of cache, but it makes sense. You've got relatively slow SSDs, you've got relatively fast RAM. You can't necessarily scale either of those in the direction you want to go, so you put something in the middle, and that thing in the middle is Optane.
So, post ODF, I know I'm going to IFA in Berlin in a week. What's on your plate?
What's on my plate? Well, I've had a few people asking about some video card reviews. Things like Radeon, RX 470, RX 460. So those will be coming out here over the next couple of weeks as we get things wrapped up. And then NVIDIA also announced a new video card today. More or less new, I should say. The GTX 1060 3GB. This is a bit of a weird card, and I suggest you read the full story on it for complete specs and details. But essentially, it's called a 1060, but it's actually a slightly cut-down version of the card. But one of the 10 SMs is disabled. So it's not the same GPU.
So is it designed? Is the cut-down version? Is it designed to come down to a lower price point to more accurately match the RX 480?
Exactly. It launched at $199, and even this afternoon, a couple hours before we started recording this podcast, you could still buy it for $199, and that is solidly in RX 484GB territory. NVIDIA and their partners are being very aggressive on pricing here. It's $50 cheaper than the standard GTX 1060.
That's weird. I thought NVIDIA didn't compete on price.
Yeah, it is strange how that works, isn't it?
They don't compete on price at the high end, but when they want their market share back.
Yes, the whole market situation with video cards right now is a little bit weird. Supply has not been great. Actually, there are only a couple of RX 480s even in stock in Newegg as of this afternoon, whereas GTX 1063GB were bound. So, strangely, NVIDIA sort of has the $199 market to themselves as of this very second, simply because AMD's partners haven't been able to keep the 4GB RX 480s in stock.
Hey, being in a position where you can sell as much as you make is an investor's dream.
It is an investor's dream, but at the same time,
it stops at one point in the future.
If you don't have more to sell, then you've limited yourself, and you could have been making even more money.
So, that's IDF. Thanks, Ryan.
Thank you, Ian.
Thanks, everybody, for listening.